So now, to find domains and ranges from a graph, this is what we're going to do. Again, coming back to the definition for the domain is the set of the set of the elements on the x coordinates, if we will, and the range it's about the elements that lie in the y value. So in this case, now that we have these graphs are a set of infinitely many points, right? Well, so we are going to describe those domains and those ranges. Well, the first couple of exercises might take a while to determine how do we look at them, but after a while you'll see how it works. Essentially, when it comes to looking at a graph, to find the domain goes along the x-axis, the range goes along the y-axis. So this is what we're going to do. We are like cameras. We are going to scan the graph from left to right to determine the domain of a function. And then we're going to scan the graph from bottom to top to determine the range of the function. Now, here is the thing. Notice something interesting, and that's what usually makes it tricky to visualize. What are those arrows? Okay, notice this V-shaped graph. Well, it's going diagonally towards the left. But do you notice the behavior of that diagonal line? Besides going, to the right, it is also going up. All right. Well, in some cases, the curve or the line is not as steep like this. That we may not be able to see the behavior for both going to the right and to the left. To the right and up or down. But in this case, well, every time you see arrows, my advice is do the following. Break down this diagonal arrow like this to indicate that it's going to the right and also up. Do the same on the other endpoint, because this diagonal line indicates that the points are going towards the left, but they're also going up. So they're going to the left and they're going up. All right, now how are we going to determine the domain for this function? Well, check this out. Domain. So the domain, and I'm going to write it in interval notation first of all, and then I'm going to go set notation. I know the instructions say otherwise. Let me do interval notation. Okay. So here is the thing. If we scan the graph from left to right, all right? Okay. Coming from the left, well, what is that arrow indicating? Isn't that going all the way forever on the negative side? And that other arrow is indicating that this function is going all the way forever on the positive side. Another way to say negative forever to positive forever, how about simply negative infinity to positive infinity? All right? Well, why is that? Because if we look at all the points that we can see from the graph, we don't have any holes in between. We don't have any jump discontinuities in between or other gaps, so to speak, or asymptotes. We're going to talk about asymptotes later as well. So it's, in fact, you can see this is a smooth curve, if we will. It's a well-behaved curve because no holes, no jumps, etc. Now, how do we express the domain using set builder notation? And here's where we refer to the previous handout where we use x such that x belongs to the set of all real numbers. Let me write it in words how we read it. So x such that x belongs, this little e, it's not an epsilon. It looks very oftentimes it's regarded as an epsilon, but it's not an epsilon. It's just a symbol to say belongs to. Belongs to the set of all real numbers. All right. What do we have? interval notation, fancy set builder notation, and words. We don't have to do the words at all. I just did this one in particular just to remind about how we interpret this, what this bar means. This bar means such that, the little e means belongs to, and the stylized r, which is not a regular r, means it's a set of all real numbers, all right? Now, what about the range? Let's see, range. For the range, now, for the domain, we scan the graph from left to right. Now, we're going to scan the graph from bottom to top. All right, and well, in this case, when we scan the graph from left to right, there were no bounds toward the left, and there was no bound towards the right. That's why the domain was a set of all real numbers, or negative infinity to positive infinity. However, when we scan the graph from bottom to top, actually the graph doesn't go all the way down to negative infinity, right? Actually, there's a minimum or smallest y value. Can anyone identify what's the y value? -5. Now, we're going to start at -5 and scan the graph like a camera all the way up. And now, what do these arrows indicate? Go forever, right? So you're going to lift your camera forever all the way to infinity. That is, what's that? -5 to positive infinity. Notice I put brackets for the -5 because here I see a solid point. It could be the case in which this could be an open circle, all right? And well, in this case, that'll change the way we would describe the range, all right? Well, that's in interval notation. Now for set builder notation, careful because this is not about x. This is rather about y, such that, well, in this case, we are going to rewrite this interval in terms of an inequality. And again, we're going to start at -5. The fact that it goes all the way to the positive infinity, that means -5, or rather, hold on, no, y greater than or equal to -5. All right, that's what that interval represents. All the values that are greater than or equal to -5. All right? And furthermore, the question is that graph representing a function or not? Function or not a function? Function. So if we trace a vertical line, it's nowhere going to cross at more than one point. You can try infinitely many possibilities and it never crosses more than one. So in this case, function, right? So it is a function. All right, let's look at the next example, our second example. That one looks like a circle, and well, again, in comparison with the previous example, we don't see any arrows indicating that on one side is going to go forever, right? So it looks like we're not going to have that infinity symbol involved here. However, we are still going to use the same technique of the same camera technique, scan from left to right, for the domain, scan from bottom to top to get the range. All right, if it works for you, draw imaginary bounds. What do I mean by imaginary bounds? Well, when I have this kind of closed regions, I go to the smallest value of x, and I put a dashed line. All right, that's just to indicate what's my smallest value, so I can easily find my smallest value of x. And I'm going to do another one to find my largest value of x. All right. And I'm going to do the same one. I'm going to use a different color in order to easily find the range. And in the same way I went, the smallest possible x and the largest possible x, I'm going to go the smallest value of y towards the largest value of y. All right, and that's going to give us the window, if you will, the window for the range and the window for the domain. That's another way to interpret it. And I think from here we can easily describe, I think, the domain. All right. Okay, scanning from left to right. What's the domain? Negative 2 to 2. All right, I'm going to write negative 2 to 2. Now we need inclusion exclusion symbols, bracket for both, right? Because, well, at these endpoints, we have solid points. We could have open circles just to mess things up. But, well, let's keep it simple for now. We're going to get into those, don't worry. All right? And, well, writing this using interval notation, set builder notation, that's x such that, well, x goes between negative 2 and positive 2. The inequality symbols we use with the equal at the bottom because we are including the endpoints again. All right? Any ideas as the range? 0 and 1. 0, okay, starts scanning from bottom to top. Well, the smallest value is 0. It's going to go all the way to 4, right? All the way to 4. So domain or range rather. 0 to 4. Notice again, I'm using brackets at this time, right? And in this case, it's not x, it's y, such that y is greater than or equal to 0, but less than or equal to 4. Question?
Moving forward in the class, because it's not really clear whether it's closed or open, should we just assume?
Oh no, we don't assume. That's and I'm glad you stopped me here, because why am I using brackets, which mean closed as opposed to open, which is parentheses? That's because we have a solid point here. So check this out. How can it look different? What if I have this region here? So what if I have this circle, but instead of having a solid point, make it an open circle, all right? So in this case, yes, the lowest endpoint is still negative 2. However, we no longer include it. We would put parentheses around this because they're open circles. We don't include those values, as opposed to here. Essentially, we have a bunch of full circles on the edge of the circle. All right, that's what makes a huge difference here. All right. Function or not a function? Not a function. All right. Not a function. All right. All right. Okay, I'm going to wait a couple of seconds in case it still needs to keep writing anything. Okay. We ready for the next one? All right. Actually, how about you guys try this one? So when it comes to this sideways parabola, which is the shape we have over here, well, again, same technique. Scan from left to right for the domain, scan from bottom to top for the range. Now, here is the thing. Comparing this parabola, and that's what I mentioned earlier, comparing it with this line, well, the line, it's clearer for us that it goes towards the right and up, and towards the left and also up. However, this parabola right here looks like goes more to the right than it goes up and down, right? But trust me, it still goes up and down. How do we know? Because of this arrow right here, that the fact that we have that arrow like that, that indicates we can break up this arrow the following way to say that it goes to the right and also goes up. And yes, I agree, if you're thinking that it doesn't go up as quick as it goes to the right, yes, you're right. However, it is still going up. This arrow indicates right, but in this case, down. All right. Now let's scan the graph from left to right. So domain, the domain will be, okay, bracket 0 to all the way to infinity. Well, why did I use bracket? That's because it's solid here, and it goes all the way to infinity because of the arrows pointing towards the right. All right? And using this in interval notation, that's x such that, well, x 0, in this case, greater than or equal 0. All right? What about the range? What do you got for the range? Yes.
Parentheses, negative infinity to infinity.
That is correct.
And y would be all real numbers.
All real numbers, and y such that y belongs to the set of all real numbers. All right? Yes, and how do we know it's negative infinity to positive infinity? Well, we have the arrow pointing down and that arrow pointing up with no holes in between. Well, that's how it's pretty much all real numbers. All right? Function or not a function? Not a function. All right, not a function. What about, okay, the next graph is very similar to that one that we got in the previous one. However, that graph doesn't have those arrows going on forever. All right, so that's going to be a game changer here. So let's see how does that change the game here. Well, so again, same technique. Scan from left to right for the main. Scan from bottom to top for the range. But notice in this case, well, still starts at 0. However, the maximum value of x doesn't go all the way up to 4. And notice the endpoints have solid bubbles here. I made those solid bubbles explicit to distinguish it from what we're going to do in the next exercise. All right. So domain. So that's going to go, okay, if it works for you, again, you might want to do the bounds, the imaginary bounds, so you can, in a way, delimit the window of your function. And in this case, notice how it goes from 0 to 4. And in this case, notice 0 to 4. In both cases, brackets, because we have solid points. The next exercise, you'll see how it's going to be different. All right, so that's going to be then, okay, using set builder notation, x such that x is greater than or equal to 0, but also less than or equal to 4. All right? What about the range? Okay, scan from bottom to top. Scan from bottom to top. Well, in this case, the smallest value of y, what's that going to be? Does anybody have the answer for the range, by the way? Yes.
The range will be bracket -2, +2 bracket.
-2 to 2, which is in this case y such that y goes between -2 and 2. Whoops. All right. Function or not a function? Again, not a function, right? All right. So, domain. Very similar to the previous exercise. I mean, just scan from left to right. It's still going to start at 0, including the 0, because we have a solid point. However, using these open circles at 4, we had full circles at 4 in the previous example. Now we have them open. What would that mean in this case?
not equal to 4.
So it's not equal to 4. So in this case, yes, it's still equal to 0, but not equal to 4. We exclude the 4. And well, that means x such that x varies between x equal to 0 and just less than, not less than or equal to 4. All right? And range, that's going to go, well, same. It's going to go from -2 to 2. All right? However, the difference this time, because of these open circles, that's going to mean excluding, and instead of representing this using brackets, we're going to represent them with parentheses. That means y such that y less than, greater than -2 and less than 2. All right? And function or not a function? Not a function, right? All right. Let's see. I'll let you work on the last one. All right. The example at the bottom, we have this curve somehow pointing towards the left. And again, careful, this could be a little bit misleading when interpreting these graphs. Because yes, it looks like it's going flat and it looks like the maximum value could be 3. However, if we extend, it still keeps going up in the y direction. So the proper thing to do before attempting to find the domain, before scanning from left to right and bottom to top, again, break this up into these two arrows, one to indicate that it's going to the left and another one to indicate that it's going up. And now we're ready to scan from left to right to get the domain. So domain, well, scanning from left to right, any ideas? Yes.
It would be parentheses negative infinity to 4 bracket.
All right.
The notation would be x is less than or equal to 4.
That's correct. All right. Someone else, what about the range? Yes.
I got bracket 4, infinity, parentheses, and then y such that y 4 is less than or equal to y.
Okay, let's have a look at that 4. Okay, so hopefully what we did here is to scan the graph from bottom to top. All right. What's the smallest value on the graph for y?
So for y.
For y, when we scan the graph, right? 0, because again, check this out. So our lowest value of y, it's this point right here corresponding to y equals 0, and then the graph just grows up all the way to positive infinity. All right. So yes, I know yeah, you were looking at the x value, and that's a very common misconception in this case because again, keep in mind domain left to right and bottom to top for range. All right, so let's see. So that's going to be range. That's going to be from 0, and in this case bracket, to actually infinity, which means y such that y is greater than or equal to 0, right? Function or not a function, by the way? Function, right? All right. Would you like to try the next one? Every time you see a graph like this containing arrows that somehow indicate that the graph extends indefinitely, break them up in accordance with the directions. That is, to the right and up, to the left and up. That helps us easily determine the domain and the range based on how it goes. Because again, now if we look at this diagonal line, that goes up faster than it goes to the right. It's not like the first problem in which it went equally to the left than it went to the right. So no, in this case it goes faster up than it goes to the right or to the left, but we still have both directions in this case. So let's see about this one. So domain. Scanning from left to right comes from negative infinity, goes all the way to positive infinity, right? No problem. How do we know? Because, well, we don't have any holes in between. You know, it's defined for all values of x, no problem. And the range, all right, for the range, scan it from bottom to top. What do we get when we scan from bottom to top? Negative 3 to infinity. Okay, so negative 3 to infinity. However, which grouping symbol for the negative 3? Bracket, right? Now let's write this using interval, or rather set Bueller notation, that is x such that x belongs to the set of all real numbers, and y such that y is greater than or equal to negative 3. All right? Function or not a function? Function. Okay?